Welcome to the Abstract Factory Design Pattern presentation by Brianna Hansen. What is abstract factory design? Mapleston, Hosking, and Grundy says the abstract factory interface declares the set of abstract create operations that the concrete factories will implement. So let's explain this a little bit further. So this is an interface that is going to call how to create the factories. It doesn't, and the products, it doesn't actually create them, it just calls the functions to do them. This technique uses a creational design pattern, which is used to create objects, but it hides how the objects are created. So a user can't see how the object is created, they just know that it is created. And it's an interface to create concrete factories. So it goes and calls the concrete factory method and creates the objects in the factories. And it's also a super factory that creates sub-factories. So it's the main factory that tells everything else what to do. To help illustrate how the abstract factory design pattern works, I provided an example using the HeyFit application. This is a diagram showing how the abstract factory design pattern works. On the right, we have a client, or our main class, which comes across and calls, for example, the Apple or the Garmin concrete factory class. And those implement the abstract factory interface. The concrete factories are actually what instantiate the objects. Here we have our main class, and in this we have the Apple device factory get device factory, and we can use this to call as many Apple devices and to get the devices as we want. And with those, we'll also have the methods of connect device and retrieve data, which are specified in our abstract factory interface. Next, we have the abstract factory, which states that all classes must have the get device factory method. These two concrete factories are examples that we would use for Garmin and Fitbit, as they extend the abstract factory and then return the get device for a new Garmin and a Fitbit. This is an example of an abstract object interface, where we have public interface device, and then we have two methods inside of it, connect device and retrieve data. These do not have bodies, and they're just the interface method, stating that anything that implements this interface has to have these two methods defined. This is followed by the concrete object class. This is an example of an Apple that implements the device interface. We have public class Apple implements device, within which has the connect device and retrieve data. This is where we would put the customized code in order to connect an Apple device and retrieve the data from it. In our second concrete factory class, we can see that the same type of code is written, except this time it's for Fitbit. Again, as with the Apple, the connect device and retrieve data methods must be included, but this time the code that is inside of those methods will be different, as it will be customized for the Fitbit. And also we would have similar code for Garmin, as we want it for each of our devices. In the last concrete factory class, we have public class Samsung implements device. So we can see that each of these classes, the implements device, are forced to use the same methods, connect device and retrieve data. This provides consistency over the classes and the design. Why would we want to use abstract factory design? There are two pros towards using this. The first is we can access and switch between data sources. This would be very useful when we're trying to access Apple, Garmin, Fitbit, and Samsung devices and data sources. We can also separate out concrete classes. So this also gives us the option to separate out the 4 types of devices to write the code we would need to be able to connect and retrieve the data for each of those. Now for the cons of abstract factory design. The first is it has complex handling and inheritance, as we saw from the diagram earlier. When you make changes, there wind up being lots of changes in the client or application that need to be done in the code. The second is that adding new concrete classes is difficult. Every new concrete class you add has to have a method written to go with the interface that it is implementing. This requires writing quite a bit of code for each class. However, there are times when there is a recommendation to use abstract factory design. The first is when the application needs to be decoupled from instantiation and you would like to have those separated. The second is the application works with multiple families of classes. And the third is when you need to enforce a constraint, as we saw earlier with our example, that every method had to have the connect device and retrieve data method inside of it, and that was enforced by implementing the interface. So, how well do you remember what was talked about? I have 3 questions to share with you and the answers. Which of the following are true about the abstract factory design pattern? Our options are: it is a creational pattern, it can directly instantiate an abstract class, it is an interface to create concrete factories, it hides how objects are created, and it only allows one data source. The answers are: it's a creational pattern, it is an interface to create concrete factories, and it hides how objects are created. Question number 2. What are 2 recommendations for when to use the abstract factory design pattern? Our options are: the application needs to be decoupled from instantiation, the application works with only one family of classes, the application works with multiple families of classes, and the components are not designed to be used as a collection. The correct answers are: the application needs to be decoupled from instantiation, and the application works with multiple families of classes. Question number 3. What are the 2 cons of abstract factory design? The options are: complex handling and tree data structures, isolates concrete classes, adding new concrete classes is difficult, and accesses multiple data sources. The correct answers are: the cons are complex handling and tree data structures, and adding new concrete classes is difficult. Following are the 9 sources I used to create this presentation. I hope that you learned about abstract factory design and understand better how it can apply to our project, the HeyFit application. Thank you again for coming to my presentation.